Hello everybody, my name is Harrison Schmid, and I worked in collaboration with Branham and Khalib Morton to present to you our research project on emerging techniques and technologies of artificial intelligence and machine learning. Since the turn of the century, technology has been increasing at exponential rates. Because of this advancement, scientists have begun to develop new research into technology known as artificial intelligence, or AI. This research and technological advancement is the future of the computer science and engineering industries. In this presentation, we will explore 14 robots that are either in the market already or under development. Let's start with Digit by Agility Robotics. Digit is designed for moving around in difficult terrain and moving packages. This model has a humanoid design with 2 arms and legs, but some models have 4 arms and 2 legs. The arms are given 4 degrees of motion, which include front to back and side to side motion, while the legs are given 2 degrees of motion, which is just front to back. It uses a combination of Intel RealSense cameras and LiDAR to navigate its terrain. Digit can also be disassembled and packed in less than 5 minutes, which makes it convenient to transport. Ford Motors has already pre-ordered 2 of these robots to deliver packages from their self-driving vans. Next up is Pepper by SoftBank Robotics. Pepper is a humanoid robot designed to recognize faces and human emotions. It has a variety of uses ranging from customer sales to becoming a learning tool for children. Pepper features animated speech and expressive listening modules which allow it to show human-like behavior. It also has an autonomous life module which enables it to appear more lifelike and emulate a personality. Now we will explore Atlas by Boston Dynamics. Atlas has a complex understanding of physics, which allows it to move with human-like motion rather than having its movement hard-coded. This allows it to be agile and make complicated maneuvers such as flips. Atlas is a lightweight robot built with 3D printers which enhances its mobility. Its AI observes its terrain and learns how to navigate it more efficiently with each trial. In one case, it took Atlas 40,000 trials to learn how to navigate its terrain. Now we will look at Spot by Boston Dynamics. Spot was developed to move around terrain with ease and even carry objects while doing so. It is equipped with cameras, sensors, and a texture projector, which allows it to navigate in poor lighting. Spot is a quadruped, which enables it to move faster and even navigate stairs. Spot is guided by a controller, but its AI chooses how to maneuver through and around the obstacles in its path. Spot is a multi-purpose robot with many potential real-world uses, including delivering objects, navigating dangerous environments, and even entertainment. None of these options are exclusive to each other, which increases Spot's potential. It is already being released into the field for real-world testing. Up next is HRP-5P, which is a construction helper robot designed to work in areas that are considered too hazardous for humans. It uses a combination of AI and human operator to navigate these environments. The person works at an operator control system, or OCS, to help the machine decide where to go while the AI figures out how to traverse the area. This machine's operations are controlled through hardware called RTCs, which allow the robot and operator to communicate in real time. Serena 4 is the 4th generation Serena robot being developed in the University of Tehran in Iran. Serena is designed to figure out the correct force necessary to handle delicate objects without breaking them. This is done through sensors in the fingertips, gauging an object's stiffness to determine how much force is necessary to lift it. One way this can be tested is with the Kalman filter, which analyzes the area around the object as well as the object itself to give the robot the location of the object it is trying to lift. Here we have Aibo by Sony. Aibo is designed to be as lifelike as possible with the ability to learn and display emotions like a dog would. It moves around by using a combination of sensors, gate generators, and image interpreters for its AI to interpret where to go. Its legs are designed in a way which allows them to operate as wheels and legs simultaneously. Each leg is equipped with 6 parameters to allow the legs to predict and move optimally. One study ran a generic algorithm on the robots to allow each generation to receive information and mutations based on the walk cycles of their parents. This study ran for 50 generations amongst a population of 20 Aibos. The end result of this study proved that this method was inefficient for machine learning. Now we will move on to Aquanaut by Houston Mechatronics. Aquanaut was developed as a way to improve the way oil and gas lines are maintained in the ocean. It features 2 states. The first state is its submarine form for traversing the ocean. The second state is a half-human form designed to complete tasks. Its AI is being designed to enable the robot to complete tasks on its own and react to its environment autonomously in case communication is disconnected or unavailable. If the development of Aquanaut is successful, it will reduce the number of humans who need to endanger their lives to complete high-risk missions. Some of these robots are already being sold to companies that need them. Up next is Lynx with Amazon by UBTech. Lynx is the first robot to have Amazon Alexa integration. It has 18 degrees of freedom for stability and speed and is capable of being voice activated by integrating Alexa's technology. Lynx can be used as an avatar by activating avatar mode, meaning the human operator can see what Lynx sees and use a microphone to speak through Lynx's speakers. It also features surveillance mode, which uses motion sensors to alert the user if any movement is detected. Now we have RoboBees by Wise Institute. These are autonomous flying microbots inspired by the design of, you guessed it, a bee. They are about the size of a paperclip and only weigh 1/10 of a gram. They can fly and hover in the air or dive and swim in the water. They use soft actuators which allow them to perform these dives without damaging themselves. In the future, RoboBees may even be used for crop pollination and search and rescue missions. Let's take a look at Sophia by Hanson Robotics. Sophia is one of the most realistic autonomous humanoid robots. She has been featured on The Tonight Show, Jimmy Kimmel, and Good Morning Britain. Sophia comprises of many intricate parts, including symbolic AI, neural networks, expert systems, machine perception, conversational natural language perception, adaptive motor control, and cognitive architecture. Sophia can operate fully autonomously or with the script of human-generated words. She can be used to assist in medicine, education, co-work, and science research. The idea of Roomba dates back to 1989, but advancements in technology were necessary to actualize the dream. iRobot took on this task and created the first hands-free vacuum cleaner robot available on the market. It has a simple design, and its AI navigates in a patterned motion to maximize floor coverage within its given constraints. The operator chooses these constraints with lasers, which section off the areas the user wants cleaned. Advanced models can even clean corners and move through tight spaces. Our next robot slithers through hazardous terrain as well. They are known as snake robots. These are still in the prototype phase, but they are being designed for search and rescue missions to get people out of tight spots. The current model is still learning how to navigate difficult terrain, and it uses a system of links and wheels which keep it flexible as it goes over bumps and obstacles along the way. At the moment, only operators with specialized training can use the robot, but to be commercialized, it will have to be more user-friendly. And finally, we will investigate assisted walking technology. This technology is designed with the elderly and disabled in mind. Walking is a difficult task to teach a robot because of all the variables, but the specific model we have researched assumes the user has one good leg and one bad leg. This is called the walking suit. The dominant leg is equipped with an encoder, while the other leg is equipped with a motor, and works in two phases, stationary and moving. During the stationary phase, the leg with the motor has to stabilize and balance the body, while the leg with the encoder analyzes the motion of the moving leg. Once this step is taken, the encoder tells the leg with the motor what action to perform to complete a stepping cycle. Robots have many uses, and their utility can range from medical to commercial to educational and much more. Robotic design and programming is the future of the world, and we have already seen some of these robots released for consumer use. Roomba, Aibo, and Pepper are all robots that can be purchased and brought home today. Robots like Digit and Aquanaut are still being tested for commercial use. If RoboBees are successful, they may unlock new ways to improve the environment. In the right hands, technology and AI can be used to improve daily life and even the world. Thank you for listening to our presentation on emerging technologies and techniques in AI development and machine learning. I will now show you our list of sources and references that we used for this research. Have an excellent day.